Hey, geometry! We've made it to the second part of the chapter, which deals with volume. This lesson specifically is on prisms and cylinders. Little recap here on what volume is. Hopefully it's a review. Done this probably since elementary school. But volume is the space that a figure occupies. So how much of something can I put into my solid? The technical term would be, the reason why it's called units cubed is because you're actually wondering how many little cubic units can I place into this bigger solid. So that's why when we label it's centimeters cubed, because it's literally talking about how many of these unit cubes can I fit into that solid. This is just a picture to show you that it doesn't matter if you have a prism that is straight up and down or one that is oblique, aka slanted, that as long as they have the same base dimensions and height, they have the exact same volume. It's just this guy right here is pushed over to its side. So the formula is still the same, everything's still the same, it's just kind of pushed over, whereas this one is straight up and down. So let's just get right to it here. How do you find the volume of a prism or cylinder? We say the volume equals your base area times height. So big B right here stands for base area. So it's just our generic formula because obviously we have different types of prisms, like a triangular or rectangular prism, have different base shapes. But as long as you take the area of the base times its height, it will give you the volume. Similar here, we have a circle, pi r squared times our height will give you the volume of a cylinder. So base area times height. What is the volume of this rectangular prism at, right? So again, volume equals base area times height. So let's see here. Here's my base shape, 5 by 3. So I'm going to have 5 times 3. And what's my height? How high does it go up? 4. So times 4. So 5 times 3 gives me 15. Times 4 is 60 feet. Remember, cube, because we could fit 60 1 centimeter by 1 centimeter by 1 centimeter cubes into this rectangular prism right there. Reasoning says, suppose the prism at the right is turned so that its base is 4 by 5 and the height is 3. Does the volume change? Well, let's see here. So again, base area times height. Our base this time they're telling us is 4 by 5. 4 by 5. And our rectangular prism would have a height of 3 times 3. So let's see what we would get. 4 times 5 is 20. Times 3 would give me 60. Again, so is there a difference between these two answers here? Nope, they're the same. No. Results in the same volume. Good job, guys. Okay, now we're moving on to a triangular prism. Keyword there, triangular, aka that's telling us what our base is. So for me, I'm going to trace out that triangle so I know what my base is. But again, remember volume equals base area times height. So my base area, we said, is a triangle. How do you find the area of a triangle? Half base times height. Well, what's your base of that triangle? 6. What's the height? 10. So half times 10 times 6. And then the height of that prism, guys, how far is it going back? It's going back 5 meters, so times 5. Now just crunch it out. Half of 10 is 5. 5 times 6 is 30. Times 5. 30 times 5 is 150 meters. So remember, base area is whatever your base shape is. So a triangle, that's why that one was different. Another reasoning here says, suppose the height of a prism is doubled. How does this affect the volume of the prism? Well, let's just double the height of this triangular prism here and see what happens. So instead of taking 30 times 5, let's take it times 10. Let's pretend that this went back 10 meters instead of 5. So 30 times 10 is 300. So how does 150 and 300 compare? Well, it's twice as big, so the volume doubles. If the height is doubled, then the volume is doubled. Okay, good job, doing great. Multiple choice, what is the approximate volume of the triangular prism? All right, let's see what we have going on here. Let's use brighter color. All right, so this is 8, 8, and they're telling us that this guy right there is 8, so there is another 8. So I have an equilateral triangle, so that makes our life a little easier because, now it's pretty simple to find our height. So I know that this is 4. Now how do you find your long? If your short's 4, well it's 4 square root of 3. Those never go away. Volume equals base area times height. Again, we have a triangular prism, so yeah, that's your base of your triangle. This is 8. What's the height? We found to be 4 square roots of 3. And what's the height of our whole prism there? It goes back 10, so times 10. Half of 8, 4. 4 times 4 is 16 square root of 3 times 10. 160 square roots of 3, which is approximately what? 277 inches. Ooh, moving on to cylinders. These are pretty simple. What's the volume of the cylinder in terms of pi? Keyword there, don't multiply it out. So again, volume equals base area times height. Well, what's our base shape? It's just a circle. How do you find the area of a circle? Pi r squared. So now let's just plug it in. Base area, pi. What's my radius? 3 squared times our height. Well, how tall is our cylinder? It's 8. Now just crunch it out. 3 squared, 9 pi, times 8 gives me a total of 72 pi centimeters. Good job. Okay, here's an example of an oblique cylinder. Do you guys see how it's kind of pushed off to its side there? It's not straight up and down. That's all right. It's still the same process. Volume equals base area times height. Again, pi r squared. What's our radius here? Our diameter is 2, so my radius is 1. So pi 1 squared times what's our height? How tall is our cylinder? Well, it's 3 times 3. 1 squared is 1 times 3 gives us 3 pi meters. Nice work, everyone. Okay, to the last page of your notes, please. So now we have to work backwards. It's still the same process. So it says the volume of a cylinder is 135 pi centimeters cubed. The height of the cylinder is 15 centimeters. What's the radius of the base? So again, just start off with your formula. Volume equals base area times height. Well, what is our base again? Well, it's a circle, so I know my base area is pi r squared times height. Now let's plug in what they give us. The volume of the cylinder is 135 pi. So that's going to go over here. 135 pi equals pi. Do we know what our radius is? Nope, so that stays as a variable. And then they tell us the height of the cylinder is 15 centimeters, so times 15. Now we just have to get r by itself. So let's first get rid of our pi's. So how do you do multiply by pi? Divide by pi. Divide by pi. Divide by pi. So those cancel, these cancel. So now I'm left with 135 equals r squared times 15. Now how do you undo multiply by 15? Well, we're going to divide by 15. 135 divided by 15 is 9 equals r squared. That cancels out. Now how do you undo something squared? Take the square root. Square root of 9 equals 3. So our radius is 3 centimeters. Okay, going to our last one here, guys. So it says a composite space figure is a three-dimensional figure that is a combination of two or more simpler figures. You can find the volume of a composite space figure by adding the volumes of the figures that are combined. So our question is, what is the approximate volume of the bullnose aquarium to the nearest cubic inch? So here's what our aquarium looks like. And then they're so kind and break it down into what it would be in simpler figures. So all we have right now is a rectangular prism, which is this guy right here. And this is half a cylinder. Well, lucky us, we know how to find volumes of both of those, so we're just going to do them individually and add them together. So let's start with the rectangular prism. So remember, volume equals base area times height. Here's my base. That rectangle there, which is 24 by 36. So 24 times 36. And how tall is our prism? Well, it's also 24 inches. So now when we multiply 24 by 36, I get 864 times 24 for a grand total of 20,736. All right, we just did the rectangular prism, so now let's move on to the half cylinder. So again, volume equals, well, let's first find out if it was a full cylinder, and then we'll just divide it by 2. So volume of a cylinder is base area times height. So our base is a circle, so we're going to have pi. Our radius they're telling us is 12 squared times our height of 24. And again, this is half a cylinder, so times a half. So let's start with 12 squared, which is 144. Half of 144 is 72, so now I have 72 pi times 24. 72 pi times 24 gives me 1,728 pi. So now we have both of our volumes there. Now let's just add them together for our grand total. So our volume equals 20,736 plus 1,728 pi, which is approximately 26,164.7 inches cubed. Nice job. We just found the volume of that aquarium. Thank you guys for watching. Let me know if you have any questions, and have a great rest of your day.